Hello my dear students, I warmly welcome you to SIA Digital Classes. So in this lecture, we are going to discuss about second method of falsy position. Okay, so this is the one of the important method. So this question has asked in the previous examination 2022 June-July question paper from Osmania University. Okay, so see the statement of the question first of all. Give the geometrical meaning of the method of falsy position. Okay, so this question asked in the previous examination 2022 June-July question paper, okay, of numerical analysis from OU. Question number 3 in short answers. Okay, so therefore, give the geometrical meaning of the method of falsy position. Method of falsy position have three names: regular falsy method, the method of chords, method of falsy position. It has three names like bisection method. Okay, so we have to explain the general procedure. Geometrical meaning is nothing but general process only. How we can solve, how we can find a root of the equation by using this falsy position method. Okay, so now for the short answer purpose, these types of questions are very important. Observe carefully. The method of falsy position is the oldest method, okay, very oldest method for finding the real root of a non-linear equation. Okay, non-linear equation. Non-linear means greater than order 1. Okay, order 1 is linear equation. Non-linear means the equation which has order greater than 1, that is from 2 3 quadratic equation, cubic equation, so those type of equations. This method closely resembles the bisection method. Okay, so in some particular cases bisection method and these methods have some similarities, so therefore it is also known as regular falsy method. Majority of the peoples call it as a regular falsy method. Okay, the original name is the method of falsy position, but majority people will call it as a regular falsy method, and some of the people call it as a method of chords. Okay, method of chords. Here chord is nothing but తెలుగులో అయితే జా అని చెప్పేస్తాం. So method of chords, it is a line, curved line. We choose the 2 points A and B such that, okay, in this method also for the given equation f of x is equal to 0. Okay, so first of all we have to randomly choose A and B. Okay, so such that f of A and f of B have opposite signs. Elanti A and B ni select cheyalante, so if you substitute A and B in the given equation, consecutively they get the opposite signs, then the root of the given equation f of x lies in between A and B. So okay, that's why I clearly mentioned you this method in some cases resembles the bisection method. Same in bisection method also, whenever you take a equation, if you take the two roots, okay, if that equation has opposite signs in these two roots, then the required root of the given equation lies in between them. So therefore the equation of the chord joining 2 points. Now A is the one point, f of A is the another point. F of A is not a function, it is a value. Why? Because we are substituting A in the function, then you will get one real number. Okay, A is one real number, f of A is another real number, B is one real number, f of B is another real number. So therefore here we have 2 points. Now we have to take the equation of the chord joining of these 2 points. So therefore that is taken as y minus f of A by x minus A is equal to f of B minus f of A by B minus A. Okay, actually equation for the chord joining 2 points. For example, if you have x1 comma y1 and x2 comma y2, if you have 2 points, okay, the equation for the chord joining these two point means y minus y1 by x minus x1 is equal to y2 minus y1 by x2 minus x1. This is the original formula we studied in the school level. Okay, so here y and x are the x and y are the variables, and y1 y2 x2 y2 are the elements, okay, points. So therefore you can see here, substitute the same values here. This one is the x1 y1 x2 y2. Okay, y minus y1 means y minus f of A by x minus x1 means x minus A equal to y2 minus y1. y2 minus y1 by x2 minus x1. In this format, you can write the equation of the chord joining these 2 points. Okay, so that is taken as equation number 1. Now, in this method, the part of the curve between the points is replaced by the chord joining the points. Okay, the part of the curve between the points. Okay, so you can see in the diagram also for this method, let the approximation to the root be the point of intersection of the chord with x-axis. Okay, so now for any method we have to take, after taking the a and b values, first of all our aim is we have to take the initial root. In the bisection method we have taken x naught is equal to a plus b by 2, that is the initial root. In this method we have to take that let the approximation root to the intersection of chord with x-axis, that is x-axis ని ఎక్కడైతే ఇంటర్సెక్షన్ చేసే పాయింట్ ఏమని తీసుకుంటాం అంటే y is equal to 0 is the approximation root అని తీసుకుంటాం. సో ఓకే, substitute this y is equal to 0 in equation number 1, then you will get the first approximation. Initial approximation is y is equal to 0. If you substitute that value in equation number 1, you will get, so what is the equation number 1? Y minus f of a. Y minus f of a means y place lo 0 substitute chestam kabatti 0 minus f of a by x minus f of x minus a is equal to f of b minus f of a by b minus a. Okay, so now simplify. Okay, so therefore f of b minus f send this b cross multiplication, so therefore minus f of a into b minus a by f of b minus f of a is equal to x minus a. Okay, so now this minus a value if you send to LHS and keep that x in RHS only, then write reversely, so therefore x is equal to a minus f of a into b minus a by f of b minus f of a. అంటే ఈ మైనస్ ఏ మనకి ఏంటి, ఇప్పుడు అప్రాక్సిమేషన్ సక్సెసివ్ అప్రాక్సిమేషన్ కి ఫార్ములా డిరైవ్ చేయాలి. ఫార్ములా డిరైవ్ చేయాలంటే మనకు LHS లో ఏముండాలి, ఎక్స్ టర్మ్ ఉండాలి, RHS లో మనకు ఫంక్షన్ ఉండాలి. ఓకే, ఎక్స్ టర్మ్ మనకి ఫంక్షన్ ఎక్కడ ఉంది, ఇక్కడ ఉంది. ఈ ఎక్స్ ని అక్కడే పెట్టేసి రిమైనింగ్ టర్మ్ మొత్తాన్ని ఒక సైడ్ తీసుకెళ్తాం. So that is LHS part anamata. So therefore x is equal to a minus f of a into b minus a by f of b minus f of a. So ఈ x ఉంటే సరిపోదు కాబట్టి మనం ఏం తీసుకుంటాం అంటే, so x1, that x we can taking as x1. Why? Because it is the first approximation. Initial approximation we got y is equal to 0. Now in first approximation x1 value. So therefore a minus f of a into b minus a by f of b minus f of a. The value does not change. So therefore now apply the LCM for these values. So therefore you will get x1 is equal to, if you apply the LCM and if you simplify them, the cancellation term will get cancelled and you will get x1 is equal to a into f of b minus b into f of a by f of b minus f of a. That is taken as equation number 2. So this is the first approximation. x1 is equal to a into f of b minus b into f of a by f of b minus f of a is taken as equation number 2. Equation number 2 gives the first approximation. Okay, so now x1 ఇది చూడడానికి మీకు ఇంత పెద్ద ఈక్వేషన్ లాగా ఉంది కానీ ప్రాబ్లం సాల్వ్ చేసేటప్పుడు అదొక వాల్యూ. ఓకే, జనరల్ ప్రొసీజర్ కాబట్టి పెద్దగా కనిపిస్తుంది. while you are solving the problems, the total x1 gives one a real number. Okay, so ఆ రియల్ నెంబర్ ని మన ఎయిమ్ ఏంటి, ఫంక్షన్ లో సబ్స్టిట్యూట్ చేయాలి గివెన్ ఫంక్షన్ లో. ఓకే, therefore if f of x1 greater than 0 and ఒకవేళ సబ్స్టిట్యూట్ చేస్తే ఈక్వల్ టు 0 వస్తే x1 is the root, required root. ఈక్వల్ టు 0 ఎగ్జిస్ట్ అవ్వదు. ఓకే, సో therefore ఈక్వల్ టు 0 కాకుండా గ్రేటర్ దాన్ 0 కానీ లెస్ దాన్ 0 కానీ, ఇన్ కేస్ ఇఫ్ ఇట్ ఇస్ గ్రేటర్ దాన్ 0, f of a less than 0 అయింటది కదా, సో ప్రీవియస్ కండిషన్ లో. సో therefore then the root lies in between a and x. అంతే, సేమ్ బైసెక్షన్ మెథడ్. సో therefore okay, then we have replace small b by x1. ఎందుకంటే ఏ ప్లేస్ లకి ఇప్పుడు x1 వస్తుంది, ఎందుకంటే x1 greater than 0 వచ్చింది, a కి less than 0 వచ్చింది కాబట్టి 2 కన్సిక్యూటివ్స్ ఉన్నాయి కాబట్టి. సో therefore the second approximation is given by x2 is equal to a into f of b ఉండాలి, ఆ b ఉన్న కాడ x1 ఉంది, a into f of x1 minus b into f of a ఉండాలి, b ప్లేస్ లో x1 into f of a by f of b minus f of a అంటే f of x1 minus f of a. b ది x1 తోటి రీప్లేస్ చేస్తున్నాం. ఇదొక కేస్, మనకు కేస్ 1 అనుకోండి. కేస్ 2 లో ఒకవేళ ఈ f of x1 greater than 0 కాకుండా f of x1 less than 0 అయింది అనుకోండి. If it is f of x1 less than 0, then what is the condition? If f of x1 less than 0, then f of b greater than 0 on the previous law. So therefore then the root lies in between x1 and b. x1 and b. ఎందుకు b and x1 రాయట్లేదంటే b is the boundary, a is the boundary for those two limits. Okay, so you have to write down the values in between them only. So therefore x1 and b. Then we replace small a by x1 in equation number 2. Then the second approximation is x2 is equal to a place లో x1 ని రీప్లేస్ చేస్తాం కాబట్టి x1 into f of b minus b into f of x1 by f of b into f of x1. అంటే this one is the another case. Okay, this one is the first case and this one is the second case. Either you will get each of them. Okay, if, depending upon the sign of the f of x1. If f of x1 greater than 0, you will get this one. F of x less than 0, you will get this one. So therefore, so in this format, if you proceed if this procedure is repeated till the best approximation is reached. Okay, so as by using the bisection method, how we did that the same previous process, same the process here also we are repeating. So we have to repeat this process until we get the approximation root. So this is the total explanation of the method of falsy position, and this equation is the main equation. Number 2 is the major equation for this approximations. This is the graphical representation. Okay, so here point capital A is there and point capital B is there. What are the coordinates? A comma f of a. Why? Because f of a we got less than 0. Assume that f of a less than 0 and here f of b greater than 0. F of b greater than 0. Then if you take here small a and here for small b, so therefore the curve joining these 2 points, okay, the curve joining these 2 points is, you can take it as, so in this format, this is the curve, y is equal to f of x, y is equal to f of x is the curve, then the given equation. Now the point of intersection you can make in this format, in the straight line format. Okay, so and x0, x1, x2. So x0 we can take it as a y is equal to 0 in this general proof, and x1 is the first approximation, x2 is the second approximation. So in this format we can explain the geometrical representation of the method of falsy position. Okay, with this clear. Now here the error criterion. Error, here also you have tolerance. Okay, error criterion, that is the percentage error is equal to error criterion epsilon r is equal to same formula as we applied in the bisection method. So xr dash minus xr by xr dash into 100%. Okay, so therefore this is the error format. If you in the problem of method of falsy position, if you ask any tolerance, okay, so then you have to use this formula after approximation. After x1 you have to do equation. In the next second approximation after x2, finding the x2 value. Okay, after substituting the given function you have to find out this value, and in third approximation after finding x3 value, after substitution of the f of x3, so then you have to do this error. So that means for each and every approximation we have to calculate the what is the error between the original root and approximation root. So therefore now here note point is rate of convergence of regular falsy method is linear. Okay, I clearly mentioned you for each and every method there is a topic rate of convergence. Okay, so rate of convergence of regular falsy method is linear, that is 1. Okay, so therefore, so in the higher classes you will know what is the rate of the convergence. Okay, so therefore this is the total explanation of the method of falsy position. This question has asked in the previous question for the short answer purpose. Okay, for in the upcoming examination also these types of questions are very very important. In the particularly they are asking these types of general proof questions only. Okay, explain the procedure instead of asking the problem, explain the procedure. So you have to focus the general procedure also. So I hope you understood this problem very well. In the next lecture we are coming with the very interesting topics. So make a perfect practice, prepare well. Until bye, thank you.